Hello and welcome to Dr. Networks. My name is Ahmad Mukhtar and today is lecture number 3 of the module 2. By the way, this is a free CCNA course, and if you want to be updated with our latest videos, do share and subscribe this channel. So, native VLANs. We discussed native VLANs in lecture number 2 a little bit. About them, but didn't go really in depth that where they are used and what are the use cases, and you have some issues when you're configuring native VLANs between switches. So we will be looking at that, and yeah, here we go. Okay, to review the previous slide a little bit, we had this scenario that we had a hub in between our switches. We had two switches, and in between we had a hub device, which is a layer 1 device. So a layer 1 device doesn't understand layer 2 frames. It just regenerates those frames and just forwards out all ports. So native VLAN was a concept that was actually for the untagged packets, meaning if you had these 80s PCs, computers connected to a hub, and they were in turn connected to a trunk on switches, what they will do is they will send a broadcast, and the broadcast comes into the trunks as untagged, so they don't have any VLAN tagging on them. So maybe I want these guys to be a part of VLAN 10. I'll say the blue VLAN is a VLAN 10. So what do? I configure the native VLAN right here on the trunk to be VLAN 10. Now, as the broadcast comes in, the switch will tag them internally in VLAN 10, which is a blue VLAN, and forward that broadcast out VLAN 10 ports. So this was pretty straightforward and easy to understand, but do we have these kind of configurations nowadays? I mean, these kind of topologies don't exist anymore. You don't have hubs. Even if you had hubs, these links would be half duplex. So who's going to use half duplex? So they are highly unlikely that this is going to be any scenario. So first off, we'll see how the configuration works between the switches, and then we'll be seeing the use cases. Okay, if you've been in the network industry for even a little amount of time, you have seen this mismatch issue between trunk links. Before I get into the issue, the thing is that whenever you're configuring a trunk between two switches, you have to make the native VLAN same on both sides. Now, why is this a consideration in the first place? Why do we need the same native VLAN be on both the trunk links? This is because we want to avoid VLAN leakage. Now what that is basically if you have different VLANs on both sides of the trunks, first of all, your console will be bugging you like hell that native VLAN is a mismatch between these two switches. The other thing is, if it's a mismatch, just see what happens here. Generate a broadcast from VLAN 20. The broadcast comes in to switch B's port. It receives it. It sends it out off of its trunk as untagged, because what you have done here is you said, okay, native VLAN 20. It's not just for receiving packets, it's for outgoing packets as well. So as the packets traverse out of that trunk, they're going to be untagged. So the untagged packet comes here towards switch A. Switch A now has a native VLAN of 10. So now, as the packet is untagged, as it comes in, the switch A is going to tag it with VLAN 10, the blue VLAN. And guess what? That broadcast actually leaked towards VLAN 10. It was originated in VLAN 20. And it ended in VLAN 10 as well. Obviously, it went to all the VLAN 20 ports that were residing on this switch. But on this side, the action really happened inversely. I mean, you got that broadcast on all of VLAN 10 ports. So that's a security consideration that we should take place. So that is why, to avoid VLAN leakage, or they may also call it VLAN seepage. They have different names for this leakage. So to avoid this, the native VLAN should be the same on both the sides. Okay, there are not many use cases that I know of native VLAN nowadays, at least in the modern times. There was a time when you did not have that access voice VLAN command that basically allowed two VLANs on an access port. You did not have that before. So in the previous times, if you had an IP phone daisy chained to a PC, what would you do? You would run a trunk port. You would configure this port as a trunk, and your phone, believe it or not, has the capability to tag packets on the fly as they convert your voice into digital media and send it. It can tag packets on the fly. So that's understandable for the phone part. But what about this PC, lonely little PC? It doesn't know how to tag VLAN packets, okay? So it doesn't do that because it's a switching technology. They don't have any idea what VLAN they belong to either. Now, the concept of the native VLAN can come into play. Trunk packets, tag packets from the phone are okay and fine, but the PC is gonna send packets untagged. So now you could use that native VLAN here for your data VLAN. You could say if you had your data VLAN for VLAN 10, you had VLAN 10 for data, and you had VLAN 20 for voice. 20 packets were great because this phone is gonna tag those 20 packets, mark it, and send it to you. But the PC is gonna send the packets untagged. So when untagged packets arrive, you could set the native VLAN on this port to 10. So now you can see the use case of a native VLAN. So the other use case is not very much popular. It's basically what I use in my home. I basically have an ESXi server, which is a VM server, and I have some VMs running inside of it. Some small VMs are running inside of it. Those VMs are in their separate VLAN. This is in VLAN 10 maybe, and 20, and 30. Next up I have a switch. So I have that kind of an infrastructure. But there is also a management of this ESXi server, in orange. There's also a management actually of the ESXi server, which normally what happens is we have electricity issues in Pakistan. So what really happens is my switch goes down all the time. So I have this server running on UPS. So what I do is I take this cable whenever the light goes off and plug it in my laptop or PC, whatever I have. I plug it in and actually give myself an IP address of the same subnet of the management VLAN. In this case, I think it's 192.168.19. So I have set up this management VLAN to be untagged. So any untagged packets coming from my server will be tagged in VLAN 19. Because I have that management VLAN set up for my home network. So these are some use cases of the native VLAN. Some people don't even know that a native VLAN exists on their trunk ports because it defaults to VLAN 1. So they don't even know it's there. So if you don't, do anything about it, then it's okay. No problem, no issues at all. So I hope this has been informative for you, and thank you for viewing.